Let me give you another example of how you can use some of the soil test data. This is another example from an on-farm consult that we did. Here's a producer that had one hayfield here that is a pH of 6.0, marginal P and K values, not too bad but not too great either. And then we've got another hayfield up here. He actually managed these two fields together, so he's got one sample for them. In this case, he's got a lower pH, 5.5, P and K values that are kind of on the low side. And his question to me was, I've only got so much money. What am I going to put as my top priority? So what would you say to this producer in this case? What would you spend your money on in this case?
Hayfield 2 and 3.
Hayfield 2 and 3. What would I put out there? Lime. Okay. But I need some P and K out here too. So what should I put my money on first? The lime, right? The lime. Lime is the most important thing to address in this case. Well, you know, in this case, he actually had some soils data on other fields in this, this farm. And he had a pasture over here that was a pH of 6.2, a very good P and very good K. So in this field, he really didn't need anything other than nitrogen. And this field actually happens to be about the same acreage as these two fields over here. And I asked him, can you, actually it's a better stand too, you can kind of see that from the aerial here. Can you feed hay and graze these cattle over here in these fields and make hay over in this field? If you're going to make hay, why don't you switch those fields? And actually he ended up flip-flopping those. And in this case he saved several $1,000s because he put the lime, he went ahead and put the lime out here. But because he didn't need any P and K over here, and he needed a little bit here and maybe even a little bit of pH amendment here with some lime, he was able to come out better in the long run because he had good soil test data on all the fields on his farm. I'm not saying this works on every farm, but what I am saying is you can play around with these a little bit and make it work. And it's much better to have that data than to need it. Okay, the other thing that I want to highlight here is talk a little bit about some of the variability that we have in our fields. And you can kind of see this looks like amber waves of grain or green waves of grain, but it's what it really is pH variability in this particular field. And this can be in a very, very short range, from me to clay, from me to Adam. It can be a significant difference in pH, particularly on some of our heavily eroded, very widely eroded fields. We can have quite a bit of variation in soil pH. Now, the reason I spend so much time on talking about pH, particularly in light of dry weather, is because of the effect it has on the root system. Here's a soil pH of 6.5. These happen to be cotton roots, but the exact same thing will happen with bermudagrass roots or any others. And you can see how well developed that root system is there, but when we have a lower soil pH, particularly as we get down below about 5.8, but folks, this actually starts happening about a pH of 6 or 5.9 as well. We can begin to have problems with the root system development in these fields. And which one of these is going to be the first one to start drying up when the rains stop? And which ones are going to be a little bit more persistent? Now, just because you've been adding poultry litter does not necessarily mean that you get away from having to look at your pH issues. pH is improved by poultry litter, but this is some work that was done in some soils in East Texas that are very similar to what we have in Georgia. And notice here that as soil pHs increase here, okay, going from 4.5 all the way up even to 7.5, there is a straight line response. That pH has a straight line, linear response. The amount of yield that we're getting off of that is linearly responsive to soil pH, which means that we need to keep that pH at a high end here to make sure that that plant is getting the full benefit. Now, I want to point out this was in a dry year. Okay? In a wet year, you would see this kind of level off here, especially above about 6.5. But in a dry year, those pH environments, the soil environment that allowed a good root system to develop, will have a better time. Now notice here with the increasing level of poultry litter, okay, going from 0 up to 8 tons of poultry litter per acre. Even in that scenario, we're seeing a response here to soil pH. We're still seeing a response to soil pH. Now, as I mentioned, when we put poultry litter out, it does have a liming effect. In fact, it's about 1/10 the strength of limestone on a ton-per-ton basis. Okay, so it does have some value to that. If we look at a study that was done up in Calhoun, Northwest Georgia, after 4 years of applying poultry litter at 4 tons to the acre, many of you know Julia Gaskin, she was involved with this research. You saw an increase of 0.6 points, pH points here, over where they just applied ammonium nitrate. Whereas with in northeast Georgia, in the same situation, after 5 years of 4 tons to the acre, they saw it increase again by 0.6 pH points. In this case, it was held steady at 6.6. However, we have seen a lot of, and we get a lot of questions about the use of alum. Alum in our poultry houses to control ammonia in those poultry houses. What effect does that have on the effectiveness of poultry litter? What effect is that having in the real world in our soils? Well, let me walk you through this graph. This is some work that was done out in Arkansas, just as applicable here as it was out there. On the left-hand side here, we have soil pH, and this has soil pH in KCl. And all you need to do is just mark through that and add 0.6 to all of those points. So instead of 5.0, this should be actually 5.6 on a pH scale that you're normally dealing with, water pH. Okay? So what they did here is they started out in 0 years here, and tracked this for 8 years, using ammonium nitrate by itself, okay, ammonium nitrate with no lime addition, and you can see what happened to the soil pH here. It's dropped, got very, very low here in year 7, recovered a little bit in the 8th year, but with very, very low level here. Normal litter, okay, with the diamonds, you have normal litter up here without any alum in it, and then we have alum-treated litter, which is the circles. Right. Notice here that the alum-treated litter is better than the ammonium nitrate alone, so it's not as big of an effect as the normal poultry litter. So what we're oftentimes seeing is folks thinking that they're getting a major improvement in soil pH, but they may not necessarily be getting that improvement with the poultry litter. Now let's move on now and talk a little bit about different fertilizer tricks, and I've got a few that I want to share with you. We've got a lot more that we go into detail on in other more intensive trainings, but I want to spend some time on this one because this one is probably the biggest thing that we can do to minimize our risk from a variety of standpoints, is splitting your nitrogen applications. The research shows that if you look over the long term that splitting nitrogen applications can increase your total yields by 5 to 10%. We can full stop right there. There's not very many things that we can do that's going to increase our yields by 5 to 10%. That's a pretty significant increase. And increase our nutrient use efficiency, or nitrogen use efficiency in this case, by 25 to 30%. In other words, the nitrogen dollar that we put out there goes 25 to 30% further when we split it. The reason for this is, particularly under weather extremes like leaching, but more recently we've been talking about drought and also late freezes. It's going to get cold tonight. I don't think it's going to frost, but it's going to get cold. We've had some areas in North Georgia that were affected by the freeze we had a week or so ago. When you put out a lot of nitrogen early on, especially if you're putting out extremely high rates of nitrogen, 150, 200 pounds, and then it gets bit back, then we're going to have some real stand problems in that field as a result of that. It's a major stress. The other big thing that this helps avoid is nitrate toxicity. And every year that we have major droughts, we have some problem with nitrate toxicity. We had, I remember distinctly, my first year in Georgia was 2007, the historic drought of 2007. Of course, we haven't had really great years since either. It's been very dry every year pretty much since. But in 2007, I got a call one evening from a producer down in Madison, down in Morgan County, and they had some pearl millet that had 36,000 parts per million. Okay, that is, our threshold for feeding beef cattle is 5,000 parts per million. Actually, it's about 4,400 parts per million. So several fold over where that target needed to be, and they were wondering what to do with it. And I said, well, do you have any places that are eroding on your farm? Cover this up. Cover that area up with this hay, because that's about the best use you're going to have for that. You do not need to be feeding that to any animals. Now, we also, I mentioned some stand persistence issues, and this is a very common scenario that we've had the last several years. North Georgia, South Georgia, Florida, Alabama, North Carolina, I've been getting calls from all over because of this very issue. And there are many symptoms that we see, and as I go through this, I want to emphasize one point, is that normally with a scenario like this, there are several factors, and then you have a straw that breaks the camel's back. It's not the straw that really is the problem necessarily, it's the one that just pushed it over the edge. And as we go through this, I want to point out some of the issues that are going on here. So, what does it look like? This is a field that happened to be out early one morning over around Griffin. This was a very old, one of the original plantings of coastal. And all this green that you see is actually crabgrass. All the brown that you see is coastal. There's not much coastal left in that particular field. What were some of the symptoms that they were seeing? Poor stress tolerance, leaf spot diseases, just like crazy, or winter hardiness. Let me stop and pause on that one for just a second. Poor winter hardiness does not only mean cold hardiness, okay? Cold hardiness is how well it will weather cold weather. Winter hardiness also is influenced by how fast it greens up in the spring. And this year we've had a lot of stands that have had very major problems with winter hardiness because they really never went completely dormant, especially as we got further in the south, into the southern part of the state. So we've had some issues with that as well. Then it became just not very competitive at all. The weeds really started growing in. The grass grows very slowly, and eventually the stand was just completely gone, which is in this case. So what's at play here? One of the things we have to remember is how much we're removing in these hay fields. We're removing a lot of nutrients in these hay fields. This is bermudagrass. And assuming about a 6-ton yield on a per acre basis, we're removing over 250 units of nitrogen. Well, that's okay. Normally we're replacing most of that. But look how much potash we're removing. It's almost a 1-to-1 of the nitrogen to the potash, how much we're removing. But there's very few producers that actually put back the same amount of potash as they use in terms of nitrogen. If we were to look at orchard grass actually is higher in its potash removal. Tall fescue is actually higher in its potash removal. Now, oh, by the way, with our poultry litter, what's the average book value, if you were to look at the book value, nutrient value of poultry litter? If you look at N, P, and K ratios, anybody have a guess? 3:2, 3:3:2, depending on your management, but somewhere in there. But usually, the point I want to make is that the nitrogen value is usually much higher than the potash value. In the case of a 3:3:2 or a 3:2:2, it's a third higher. Not nearly a 1-to-1 like what we really need for potash here. So here's what happens if you apply nitrogen at 200 pounds, in this case over here, no potash. And you can see this is after 3 years what has happened to this field. There's no bermudagrass there. It's been taken over by red sorrel in this case. On the left-hand side here we have potash that's being provided at 160 units per acre. And you can see how nice and flush it is with green growth. It makes a huge difference. And it doesn't take just 2 or 3 years of running it short when we start having problems with potash.